Hello everyone, in this video we are going to use our hypothesis testing Excel sheet in order to do a one sample hypothesis test of proportions. Alright, so let's look at this. It says that only 16% of all people can wiggle their ears. Is this percentage lower for millionaires? And then of the 361 millionaires surveyed, 43 could wiggle their ears. What can be conducted at the alpha level of 0.05 level of significance? Okay, so here we have our table here, and it is going to allow us to do a test based on the summary statistics. So we were given here that 16% of all people can wiggle their ears, and we want to know, is this percentage lower for millionaires? So we'll make it lower. We're testing at an alpha level of 0.05, and the trait that we are interested in is like wiggle yes, or something like that. This is more important for when we're doing our raw data, and I'll show you in just a second. The descriptive statistics here that we need the how many said that they could wiggle their ears. It said 43, and the sample size here was 361. And now we have our sample proportion, the proportion of millionaires that actually said they could wiggle their ears, the standard error, we've got our z statistic, our p-value, margin of error, and the confidence interval here. Okay, so for this study, we should be using a z-test for a population proportion. Our baseline assumption is that pi is equal to 0.16, and the alternative from our problem is pi was less than 0.16. We got that all set up very well. Our test statistic, when we ran it in, is going to be equal to z is equal to negative 2.119, which is what we got. Now, if we are actually doing this calculation, notice in this Excel, we can actually double click on this and it'll tell you what you're doing. There's some error catching in here, but if you look at the equation, it's our sample proportion minus the hypothesized proportion divided by the standard error. Our p-value that we get is 0.0170. Our p-value is less than our alpha, and that means that we are going to reject the null hypothesis. So because of this, that means that the data suggests that the population proportion is significantly lower than 16% at the alpha level of 0.05. So there's statistically significant evidence to conclude that the population proportion of millionaires who can wiggle their ears is lower than 16%. Now, the next question is we should say, okay, what proportion do we think of millionaires can wiggle their ears? And what we would say there is that, hey, we think that it is actually 16%. And we say that, or like 15%, sorry, it's less than 15% because that's what our confidence interval shows, that it's somewhere between negative infinity and 15% is where we think that the true proportion is actually lying. Okay, let's take a look at this real quick to see how we could answer this if we were dealing with raw data. Now, my numbers aren't going to come out perfect, but just look and see what's going on. So I am going to just clear out our sample data real quick. And in here, let's suppose that MyOpenMath had given us to us, and we're just going to say, yes, 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 that these are the people who said that they could, and we'll do a bunch of no's. Now, one thing that we failed to do that we should have done is we need to do a check to see if we can even do this study. So remember that when we're dealing with a z-test of proportions, in order for us to be able to say that this binomial distribution of these like yes and these no's is in fact approximately normal. And the way that that happens is if we have at least 15 people who said that they could wiggle their ears and at least 15 who said that they couldn't. And here we have 43 who said that they could wiggle, and then roughly like 318 said that they could not wiggle their ears. So that's definitely at least 15 in both. So we're good to go. Okay, this data is wrong. I just made it up. I just typed it. But if we do here and we say that we're still saying it's 16, we want to say it's less than 16, our trait of interest is this yes. What we can do now is after we've done the yellow parts, we get our data into our orange with the column title at the top in the orange and paste all of our data down. We can now click on the analyze the raw data, and it will gather that data for you and analyze it for you just as once. And then when you're all done, you can just click clear data and it resets you back to the beginning. So pretty slick, That's how we can do a one sample hypothesis testing of proportions using our Excel worksheet.